Welcome to my presentation of our automated unit test generation framework for Python called Pynguin. My name is Stefan Lukaschik and this work was carried out at the University of Passau in Germany. Imagine you're a software engineer and what you need to do is, besides writing your code, usually you also need to provide some tests. And if you're working in a statically typed language such as Java, there are mature research prototypes available that can be used to optimize this approach and solve your problem at least partially. Imagine now you're doing the same as a Python developer, and because Python gained huge attention over the last decade, more and more projects adopt this language, and you will truly face the same problems. So what can you do? Well, you either can bang them out of the rock manually and do all this potentially time-consuming process by hand, or you're actually also aiming for an automated way to doing this. And what we proposed for this to solve this is the Pynguin test generation framework, which is extensible to allow further research in the area of test generation for dynamically typed languages, but it's also built in a way that it can be adopted by practitioners for their day-to-day work. So let's directly dive into and look at an example of a code snippet. So what we have here is a class implementing a simple queue that stores int values. So this class has a maximum size, methods to check whether it's empty or full, and of course one method to enqueue and one to dequeue the values into the queue. And we want to generate tests for this. And for that, I have also already prepared a command line. So Pynguin is a command line application, but you could also use it as part of your own code, using it like a library, or you can of course build IDE integration if you want to use it from inside your IDE. But I'm using the command line for this demonstration. So what do we have here? I'm calling Pynguin with a couple of options and parameters. So what I need to specify is the path of the project where my project files are stored. This is the current directory, and I also want to store the output in that directory in this example. And then I need to specify the module name of the module we want to generate tests for. In this case, it's called QExample, the one that we've seen previously. And additionally, I specify two further parameters, one to increase the output log level to actually see something on the command line. And I provide a predefined seed for that I know that the search process of Pynguin will converge fast to have a concise demo key. If I now hit the run button, we see a couple of lines written to the command line and Pynguin already running. And what we can see is, for example, Pynguin using a strategy and algorithm called Dynamosa, which is state-of-the-art test generation algorithm. It tells us which functions it's using for the algorithm that are used by that. And then it starts actually generating tests and uses 9 iterations of the algorithm. And we can see the coverage that is achieved by each of these iterations. And we see that after iteration, the 9th iteration, we have a coverage level of 100%. And so we were able to stop because we have all branches. So we're measuring branch coverage here with all branches already covered. Afterwards, we want to generate also assertions for that, and for that we use a mutation-based approach. Pynguin will build mutated modules from these QExamples, and here we have 30 mutants, and those 7 test cases that have been generated inside here are then executed against those, and we can see which values in the program have changed due to the mutation, and can use this information to generate tests. And in the end, we write those tests out to Python files. So if we look at one of those test files on the right-hand side here, we see, okay, well, there are some values. We create an object of this queue, check some of its properties, call methods on it, and so on and so on, and provide a couple of assertions. And these tests that you see here provide the 100% coverage that we have actually achieved. So to conclude, we have provided a tool called Pynguin, which is open source. It's available from GitHub, and we would be happy if you would like to use it and give us your feedback on your contributions and use it for your further research or practice examples. Thank you.